Yes, class. Am I audible to all of you? Abhinav and Heather.
Yes, ma'am.
Yes, ma'am.
Okay. Heather, I think you have attended the classes, no?
Yes, sir. Yes, ma'am.
Abhinav, this is your first class.
Yes, ma'am.
All right. See, Heather and Abhinav, both of you, we were doing motion in 1D, right? Vectors we had completed. No, basic vectors we had completed. Now, see, I'll be taking your electrostatics both the days. Today, we'll try to complete electric field and charges, or whatever other important questions keep on telling you side by side. And regarding electric potential, that lesson, we'll do it tomorrow. So see what all you have to remember from NEET perspective from this lesson. See, electric charge is a very basic quantity. Questions on it aren't direct. Just remember the basic value, that is 1.6 into 10 to the power minus 19 coulomb. This is enough. And you should remember that it's the weaker, see, the protons are held through weak nuclear forces and the electrons revolve around the protons with the help of electrostatic forces. But see, when we compare the nuclear forces and the electrostatic forces, the nuclear forces are very much stronger than these electrostatic forces. So what happens if a force is very weak, like electrostatic force in comparison to nuclear force? What will happen? Electrons would easily break off, right? Their bond will easily break off. In case of nuclear forces, what will happen? The bond is strong, so protons are tightly held. So you should just remember that it's the transfer of electrons that occurs. Protons do not move. And if a body has lost electrons, so the body is positive right now. And see, electrons are not massless entities. They have certain mass residing within them, right? 9.1 into 10 to the power minus 31 kgs. This much of mass is present. So when electrons are lost from a body, so associated mass with each electron is also lost. So positive, in case of positively charged body, what happens? Mass is less. Opposite thing happens in case of negatively charged electrons. In negatively charged, what happens? Electrons are gained into the body. So gaining of electron makes the body negative. So whatever is the mass that is associated with individual electrons, let's say one electron has come, so 9.1 into 10 to the power minus 31 kgs have come. If two electrons have come, so double into this. Three electrons have come, so triple into this. So likewise, mass increases for negative body. And from your charging topic, no, I'll tell you, let me discuss the methods of charging. So you basically have three methods of charging. That is charging by induction, charging by friction, and charging by conduction. These are the three methods. Since charging by friction, it's just remember in the sense that two bodies, they are rubbed against each other. So what happens? When these two bodies, they are rubbed against each other, the heat allows the electrons to get transferred. That's it. In charging by conduction, you should remember that in charging by conduction, the bodies aren't moving. You're not rubbing past bodies each other. In frictional, the two bodies were rubbed, and that rubbing, the irregularities between the bodies created the heat energy, and that allowed the transfer of electrons to occur. In conduction, you aren't rubbing the two bodies. Just place both the bodies in contact with each other, and that is sufficient. Okay, Iram. Iram, see, we are just currently discussing the first lesson of your class 12, and tomorrow we'll discuss the second, because now I'll be taking some of the portions of class 12. So I think vectors and the basics we had discussed. So we'll be continuing from that. All right. Now, charging by induction, I'll show you with the help of figure only. See, charging by induction is this. In charging by induction, you have a body that is having positive and negative charges. So this is a neutral body, right? All the amount of positive charges, this is balancing amount of negative charges. Now for separation of positive and negative charges, if I bring up a glass rod, that glass rod, let's say I have positively charged it. So what will happen? All the negative electrons, these will get attracted towards the glass rod. And so as a result, what will happen? All the positive charges, they'll accumulate at the other end. So as a result, what you will be seeing is this, right? All the negative charges at one end and all the positive charges at one end. Even if I bring up a negatively charged rod, so what will happen? All the negative charges will get repelled and positive charges will stay at a point. Always remember, positive charges do not move. It's either the negative charges that get pushed or pulled. So here in this case, if positive rod is there, negative charges will get attracted towards the end. If this was a negative rod, they'll get repelled towards the end. So as a result, finally conclusion, this is what is the scenario. Inducing charges are present on the glass rod, and induced charges, these charges which have been separated, these are known as induced charges. So remember, the charging by induction is also known as temporary electrification. Why? Because as soon as I'm holding the inducing charge, I'm holding this glass rod, the charges are separated. As soon as I remove this, what will happen? All the positive and negative charges, they'll neutralize each other and I'll get the neutral body back, right? So that's why we call this as temporary electrification. Now, class, from your NEET perspective, this is not a very, very important portion, but how questions have come from this part is basically you have to remember the basic theory points, because electronic charge E, you must have seen in your board examinations also, electronic charge E is used everywhere. But when you are specifically talking about this portion, no, electric charge, you have statement-based questions regarding negatively charged what. That's why I was saying, remember always that mass also increases and decreases for positive and negative. This fact you should remember. And from methods of charging also, you have statement-based questions. More statement-based questions are asked from this part. All right, but do not waste your time so much in this electric charge portion. You have other important topics from this lesson also. Like you have Coulomb's law. This is a very important topic. Coulomb's law is very easy formula. You should just remember that electric force is directly proportional to product of both the charges and inversely proportional to magnitude of both of it. Inversely proportional to magnitude of square of the separation between them. Now, what is the common error that is committed by students? They forget to take the magnitude. See, when I say magnitude of charges, this means you have to consider the magnitude. In one exam also, a student took -3. No, you cannot write -3. If two charges are present, one with +5 coulomb, other with -3 coulomb. So in your formula, you won't write 5 into -3. No, you will just write 5 into 3. Always remember, you have to put the product of magnitude of the charges, and it follows inverse square rule. And I'll suggest class, whenever you are revising electric charges in field is electrostatics, please try to remember and study this along with your gravitation. You have no gravitation lesson, the last lesson of your first book of class 11, because many things are related to it and most of the questions get related to it. And it's like from gravitation, either one topic comes from electrostatic, the other topic comes from it. All right. Likewise, this is the case. So that's why I try to study gravitation along with it. Because see, the way you have K, Q1, Q2 by R square, in gravitation, you have G, MM, M1, M2 by R square. So same thing. Now, constant 1/4 pi epsilon naught, this all is very easy. These all portion that K's value is 9 into 10 to the power 9. Epsilon, you should remember that this determines the medium and the force. Fine. How your medium is changing the force. Whatever is the medium, suppose you have put the two charges in glass, suppose you have put the two charges in water, suppose you have put the two charges in oil. So accordingly, force will be changed. So that is determined by. And value of epsilon naught, that is absolute permittivity for air or free space. This you should remember as 8.85 into 10 to the power minus 12. That's it. Now see what important thing is from this. This part. This part is very important, class, because it becomes very confusing. K, this dielectric constant, K, which I have been just telling you, just now we have discussed. This K is actually the ratio of epsilon by epsilon naught. That is absolute permittivity in any medium divided by absolute permittivity in free space. And force in air divided by force in medium. So it's like epsilon in any medium by epsilon in air and force in air by force in medium. So how it becomes confusing is whether it was F naught in numerator or Fm was in the numerator, right? So be careful. Epsilon will come up, F naught will come up. Otherwise, your questions will become easier. It's just that students commit error here only, and options will be given of both the parts. Epsilon by epsilon naught also, and epsilon naught by epsilon also. All right, so just remember these two portions well. Then electric field. Electric field is a very basic topic. So see, under electric field, you should just remember that this is the space around a charge where electrical properties are experienced. Repulsion, attraction, both are experienced. You should remember this formula, F is equal to QE. This is going to be used. This is actually going to be used a lot. Units, you will be able to remember it. This is the basic formula. Direction of electric field is important because more often that you can study with the help of electric field lines. That I'll discuss later. See, in superposition principle, just remember whatever is the individual electric field. So net electric field is the sum of all the individual electric. But do not directly add it. Do not directly add it. If you are having charges, you want to find out the net charge, then directly add it algebraically. But if you have numerous forces, if you have numerous electric field, then vectorically add it. If they are making some angle, consider the parallelogram law. Properly, the way vectors are solved, no, in that same manner only solve it. Dipole moment, you should remember. Firstly, you should remember the meaning of dipole moment. So dipole is what? Dipole is basically two charges that have the same magnitude. Magnitude is same, but their signs have to be opposite. If one is plus, other will be minus, right? So plus 2 coulomb, other will become minus 2 coulomb. Plus 3 microcoulomb, minus 3 microcoulomb. Magnitude should be same at any cost. And the separation between the charges, this is, let's take it as two ways. So formula of dipole moment becomes P is equal to Q into 2K. You should remember its direction. Dipole moment is an important topic from your NEET point. Electric field, electric force, these are basic quantities. They'll be used in some other concepts also, right? Like in potential also that will be used. But in your, under your dipole moment, you have this as a very major topic. This is included. Most of the questions try to include the dipole moment. So P is equal to Q into 2A. Direction will be from the negative charge to the positive charge. That's it. You should remember. Under torque also, see, for torque, no. If questions are on equilibrium, then do check whether F is equal to QE is coming something or not. If F is equal to QE isn't coming something, see, then F net is 0. It means your system is in translatory equilibrium. And if suppose you are getting a value 0, right? So it means it is in translatory equilibrium. But if QE is left, that means translatory equilibrium doesn't exist. And same goes for torque. Torque's formula is simply P cross E, that is PE sine theta, right? So if you are taking PE sine theta, you should see if torque is 0, then your rotational equilibrium also exists. If torque is coming something, your rotational equilibrium doesn't exist. So F is equal to QE and torque is equal to P cross E. You should remember these, and if questions are on equilibrium, and class questions have been coming from this part, especially as translatory and rotational equilibrium separately, and that it will try to relate it to your systemic motions of particle and rotation, your 11th class rotational motion topic. So just try to connect things. If such questions are given, no, try to connect it. Electric field lines are important from your NEET point. More than your board exams, more than your JEE exams, this is an important topic from NEET. Because in this, what will happen? Figures will be given to you. Always remember, for positive charges, electric field lines move away, and for negative charges, electric field lines move towards the charge. So what will happen? See, you will be given different figures, right? You will be given different figures. Now what will happen? Just a second, give me a second. All right. Yes. So I was saying you will be getting specific diagrams for it, specific figures. Spheres will be given. Cylinders, direct dipole charges will be given. So you have to identify the electric field lines. And electric flux is the most important topic. I'll suggest to all of you when you are revising electrostatics to start from electric flux only. Complete electric flux because this is the most important topic. And questions are also asked frequently from this electric flux, and some sort of questions have been repeated that I'll let you know. Let me discuss it then. So electric flux is what? Basically number of field lines that is crossing an area perpendicularly. Fine. So you can just count the number of electric field line. But see, every time counting the electric field lines is not possible, no? 4 electric field lines are there. I have counted. I have told you that 4 is the flux. But if such amount of electric field lines are mentioned where it is difficult, so what will happen? If such a case, then I need a proper formula for it. So formula is Es cos theta, where E is electric field, S is surface area, and theta is the angle between normal and electric field. Means this is the perpendicular and electric field. Do not take this angle from the plane. It's always perpendicular and electric field which are making angle with each other. Fine? All right. Then Gauss theorem, you should remember the statement of Gauss law. So it says that electric flux through a closed surface is 1 by epsilon naught times the total charge enclosed by the surface. That's it. This you should remember. Now let us practice some questions from this part. At least some questions practicing we should do. So same thing. I'll be writing down the question. First, you will try to attempt it. Whatever doubts you are having from this, that you can keep aside, but try it. Even if you're having some doubt, do not worry about it. Try it by yourself first. I'll in any ways discuss, but send me your answers. Let me know whatever unsuitable answer you people are getting, right? So I'll start the question. Note down the question first, write it along with me, and try it. That's what I'm saying. First attempt it. All right. So I'll write down this question. Yes, Heather has correctly answered. See, this shouldn't take so much time because the calculation part is very easy. As soon as it gives you 1.6, calculations become easier. See, in acceleration of an electron, you have to find it out. F is equal to ma. So acceleration is force divided by mass. What is force? F is equal to k q1 q2 divided by r square. That is the formula of Coulomb's law. So k is 9 into 10 to the power 9. Acceleration of electron due to mutual attraction between electron and proton. So charge on electron is also E, charge on proton is also E. So that will become 1.6 into 10 to the power minus 19 whole square divided by, what is the radius? 1.6 into 10 to the power minus 10 whole square. Fine. So F is equal to K Q1 Q2 divided by R square. 9 into 10 to the power 9, this whole square. So once you will solve this will be 9 into 10 to the power minus 9. So now put it. So acceleration will become 9 into 10 to the power minus 9 divided by 9.1 is this. I'm just taking it as 9 into 10 to the power minus 30. That is 10 to the power 22 meter per second square. Those who haven't written, note it down.
Ma'am, you told us that the in the formula k q1 q2 by r square, q1 and q2 will, like, the sign will not be used in q1 and q2, but in many questions there is the sign that is used here, like q into minus q.
Where? This is one plus only 1.6 is written. For electron, the charge is minus 1.6 into 10 to the power minus 19. For proton, the charge is plus 1.6 into 10 to the power minus 19 of coulombs. But here I have just taken the magnitude. Only this part is written. This was what you were asking?
Ma'am, actually there were some questions where this also used to be used, the sign of the quantities.
No. Sign is never used because that is a statement of Coulomb's law. When we are following Coulomb's law, then something must have been mentioned. If you are facing such question, please let me know. Share the question
Okay,
with me in WhatsApp or somewhere, because we do not put this sign. We never put the sign. If sign is put, then something else is also mentioned from it. Because sign is for the direction and magnitude of charge is just sufficient. And that is the statement of Coulomb's law, right? Because when we are following a law, we have to abide by its conditions also. And Coulomb's law is valid only if you're taking the magnitude, right? So if you're having such question, do share it with me. I'll clarify it.
okay, ma'am. Like in this question, can we say that kq into minus q by r square will be the formula that we will use in the question number 2?
Skip it. No need to write minus q. See, even it's like somewhere in the solution. No, most of the solutions mention minus q just as to signify what are they putting. Like if I just write k q square by r square right now, so it will be a confusion. No, which q is there? So some question they specify by putting plus q into minus q in this way, but at the end the minus sign isn't used. Even with in this question also, you are free to use without the sign. You will get the same answer only. Just
Okay,
take
ma'am.
the magnitude. See, in this question, it says 2-point charges A and B having charges plus Q minus Q. They are placed at a certain distance apart and force acting them is F. So if say, let's say this is Q, this is minus Q, separation between them is let's say R. So F will be K Q square by R square. Now, if 25% of charge of A is transferred to B, if 25% of charge of A is transferred, so what will happen? How much charge is left? This was 100%. Now 25 has been transferred. So how much is left? The other 75% is left. So charge in A, this will become 75% of whatever was the charge of A earlier. Fine, Q. So that becomes 3 by 4 Q, right? That is QA. Now what will happen to B? B is becoming, B was earlier having Q charge. Plus this is now receiving the other 25% of charge that A has transferred from it. Right. So what is the charge on B now? QB will become this 20Q plus this 25% of A that has been transferred. So that becomes how much? This will also be 3 by 4 only, right? Minus 3. So also be minus.
Ma'am,
Yes, yes.
won't it be like 125 by 100, something like that?
125 by, okay, this answer, you're telling me about this.
Yeah.
See, if I write down the total charge, this is QA. This part is QA. So from QA 75, this part, this much amount of charge has been lost. Right. So if QB is there, QB is gaining this part. Right. So it means 25% of charge of it. So let me write it in terms of charges only. Then it will be clear. Q.
3 by 4 amount of charge is left in QA, right?
Yes, yes, yes.
Okay.
You're right. So see, that will be 25% of charge in A, right? And then you have plus QB. This is clear till here, Iram?
Yes, ma'am.
Now see,
Understood.
this will be 1 by 4 only. Q by 4 I will write. But see, what is QB? QB is minus Q. This is A, this is B. QB is minus Q. So what you were doing, you were adding it. Now it is like plus minus Q. This is, here I have to consider the signs, no, because I am adding or subtracting the charge. When you're adding or subtracting the charge, that time you have to consider the signs. If suppose I give you plus 1 coulomb minus 2 coulomb, how will you solve this? You'll obviously write it the answer as minus 1 coulomb, right? So charges have additivity. Charges have 4 properties, no? Additive property, conservative property, quantization of charge. These properties are exhibited by electric charge. So here also, if this was amount of charge, so I am actually adding this. Minus Q is there, no? So I'm actually adding it. So when this is getting subtracted, this will also become minus 3 by 4Q. But now we'll obviously not consider the negative sign when we are putting it in Coulomb's law.
The value of minus Q in this will be 1.
Value of minus Q here.
Yes, ma'am.
This is simply minus Q. It's like Q by 4 minus Q. So that becomes minus 3 by 4Q. Value of Q you need not put. Value of Q is not even given to you in the question.
But
That
ma'am,
is
how is it 3 by 4? I didn't understand that part. How is it 3 by 4?
3 by 4 as in this is Q by 4 minus Q. So how will you take the LCM? You will multiply it by 4 and divide it by 4. LCM is 4. So this becomes 4. Q minus 4Q. That becomes minus 3Q by 4. Clear?
Yes, ma'am. So we will neglect the sign while calculating,
Yes, yes.
right?
Now see, when I'm writing new force, K, this becomes 3 by 4Q whole square because both are same. I'm not considering negative sign, right? And now
Yes,
let's
yes,
put
ma'am.
R square. So in this way, if I put it, see, F dash will become 9 by 16 separately. kq square by r square. This kq square by r square was only initial force. So how much force has increased? 9 by 16 times. So which option will be correct?
A.
A option, right? Yes. So A option is the. Note it down. Wherever doubts you have, let me know. Some questions let us see on electric field.
Ma'am,
Yes, yes, Hiram.
ma'am, I'm getting the answer as QEY by 2.
Let me discuss it then. Just check wherever error is there. See, electric force, how do we write? F is equal to QE, as I was mentioning you that this relation is very important. Now, kinetic energy, you have to write, if you remember, this is related to actually your work energy theorem in your in class 11. So, work energy theorem says what? Kinetic energy is equal to the work done. And how do you write work done? Force multiplied by the displacement. And here the displacement that is given, this is y. So force becomes QE into y.
Okay.
So
ma'am.
directly QE y. Or if you want, you can solve this by another method, but this is very quick. But just in case, what you can do, acceleration will be QE by m, right? F by m, so QE by m. If you use the equation v square is equal to u square plus 2as, so u is 0. Initially it is at rest. 2 acceleration, s is y, this is v square. Now when you try to calculate kinetic energy, this is half mv square. So half m v square will become 2QE y by m. So mm 2 gets cancelled. Alternatively, you are getting QE by. Clear? Note
Yes,
down
ma'am.
this part.
Ma'am, can you repeat this one, please?
Both the methods.
Ma'am, the work energy theorem.
Work energy theorem basically says that work done is no total kinetic energy. This is the statement of work energy theorem in your lesson, no, work energy in power. So here what happens, work done is, and the formula of work done is force into displacement. Here force is QE and here displacement is Y. So Q into Y, this is work done. So this is exactly kinetic energy. Clear, Heather?
Yes, ma'am. Yes. And we can use any of the methods like either the work energy
Yes,
theorem
yes,
or
yes.
the
This also
equation of.
kinematics equation also you can use. Acceleration will be forced by m. From here you have acceleration. This is already at rest. You can use this also. Which method is suitable to you?
Okay. Cos theta minus cos theta will give sin theta.
No, just put in the values. See, when it is saying lying along electric field, so that means theta 1 is 0 and second theta becomes 90 degree. Let me discuss it. See, when it says, no, it says that electric dipole of moment P is lying along a uniform electric field E, work done you have to calculate by rotating it when the dipole is rotated by 90 degrees. It means this is both of them, these are dipole moment and electric field. Both of them are making 0 degree. Now what is happening? Electric field is here only, whereas the dipole moment is here. So this is 90. So your theta 1 is 0 degree, theta 2 is 90 degrees. Now see what's the actual formula we use, work done's formula we use, right? So work done is PE cos theta 1 minus cos theta 2. Or if you have to reverse it, put a negative sign. So see, PE will remain at it as it is, cos 0 degree minus cos 90 degree. That's how we'll put. So that becomes PE 1 minus 0, which is, so I think option B or C.
Ma'am, how did this work done equation came along with cos theta 1 minus cos theta 2?
This equation,
Yes, ma'am.
this has a big derivation. See, you can use, but for now, no, just remember the formula. It's either PE cos theta 1 minus cos theta 2, or you can use or minus PE cos theta 2 minus cos theta 1. Any of these you can use when you have to calculate the work done for dipole moment. This is the formula for work done by the dipole moment, because the dipole has the tendency to align itself against the direction of electric field. So dipole is here making an angle 90 degree. Again, it will try to align itself back to electric field. So the work done that is generated during that time. If you want to see the derivation, I'll tell you, but derivation is of no use right now to you. Right?
Yes, ma'am. Ma'am, in what case will the minus sign be used?
Both of the formula you can use. In this also, if you use minus PE cos 90 first means 0 minus 1. So that becomes minus PE into minus 1, that is PE. Both of these in any situation. Yes, they're actually the same formula only.
Okay, ma'am.
Just be careful. What I was trying to tell you is just be careful when you're using 1 here and 2 here, plus sign here. When 2 and 1 here, then a negative sign, because you cannot interchange it.
Okay, ma'am. I'm done.
Okay, see, now only questions from electric flux is left, but we should at least do plenty of questions from electric flux. If I'll start it right now, then only one question we'll be able to do. So tomorrow, before starting with the next lesson, we'll first practice the questions from electric flux topic, revise it and come, and the next lesson. All right, so you can leave now. Please revise and come. Any doubts you have, please accumulate it and ask me tomorrow. All right, thank you.
Okay, ma'am. Thank you, ma'am.
Okay, ma'am.